Okay, multi-step equations are the follow-up to single-step equations. So yesterday we did something called single-step, where you only had to do one thing to isolate the x. And that's kind of cool because it gives us an idea of all the tools that we have. So today we're going to kick it up a notch and go to the next level, where we're going to do more than one thing. And this is two steps or multi-step. So let's look at our previous example and how we're going to up that a notch. So our previous example was like, let's say x plus 2 is equal to 8. The first thing we do is decide, what am I solving for? We say, hey, I'm going to solve for x. All right, that was hard. The next thing that we're going to do is we come up with a plan of isolating x, getting x alone. Because again, the answer is going to be x equals to something. That is my answer. I want x to be alone. Like you can see, there's nothing on the x side except x. So x is equal to, on my original equation, it's x plus 2 is equal to. X is not alone. So we have to then get it alone. So here we go. We decide, hey, I need to get rid of the 2. The opposite operation of plus 2 is minus 2. And as we mentioned before, I'm going to write the minus 2 on the bottom to make it easy on me. I chose the opposite operation because I want to make sure I realize that I can get rid of the 2's. When I get rid of the 2's, we're left with the x by itself, because 2 minus 2 is 0, and 8 minus 2 is 6. There's a couple of steps that you can add in here if you really want to. They really are a waste of time, but it's really what's going on in our brain. Like for instance, this could really be written as x plus 0, right? But that 0 is just a placeholder. So we can kind of just skip that step and make my life a little easier and save a little bit of time. Because x plus 0 is just x. So we reach what we really wanted, x by itself and x is 6. Now today, we're going to look at problems. I'm going to kick this up a notch, and I want to say instead, 3x plus 2 is equal to 8. So here is our multi-step, because we're going to go through our same scenario as before. We're going to make a decision. What am I solving for? I'm solving for the variable x. That's my unknown. Then I want to decide, what do I have to get rid of? The x side, so I can isolate the x by itself. I want to kick out everyone from my room. Kick out my mom, kick out my little siblings. This is me time. So I see I need to get rid of the 2 over here, as well as the 3. So these little bubbles here on top are my thoughts. What I have to get rid of. Step 1, isolate, like think about what's my variable. Step 2, come up with a plan. Now, here is my general game plan. When I'm solving for x, you get rid of what's farthest away. So get rid of the weakest link. But I'm going to say what's farthest away. Okay? And these little notes I write to myself are just a reminder to what I should be thinking about. And I really believe that when you guys are writing your own notes, you should write little notes to yourself. To like go write out, what were you thinking when you're writing these notes? So I'm thinking, okay, I want to solve for x. I need to get rid of some numbers. I need to get rid of the 3 and the 2. But in what order? And if it's the wrong order, it's going to mess everything up. Have you guys ever seen little kids try to take off their socks before they take off their shoes? Or try to take off their pants before they take off their shoes? Right? There's an order to things. You don't scramble eggs by cracking eggs first and then throwing oil in it. So everything in life has order. Sometimes they're kind of 50-50. Should you drink water first and eat, or should you eat and then drink water? Sure, not a problem. But in many things, there is an order. Sophia wrote PEMDAS, and that's absolutely great. PEMDAS gives us an order of operations, and oftentimes when we're solving for these, we want to go backwards. Right? We go reverse order of operations. So practically, I'm looking at this and say, who has the weakest bond? Who is farthest away from x? Is it the 3 who's multiplying, who's really next to the x, or the 2 who's farther away? When my dumb analogy of kicking people out of the room, it's if you want to kick people out of the room, you kick the person closest to the door out first, and then you work your way in, right? So the person closest to the other side, the farthest from me, is the 2. So let's talk about the operation. The 3 is multiplying, and the 2 is adding. So the 3 is a multiply, and the 2 is addition. So to think about the cancel operation, the opposite operation, and when someone mentioned the inverse operation, is going to be subtract and divide. So that's the game plan. I need to subtract the 2 and divide the 3. So let's go ahead and do that. I'm going to rewrite this so you guys can see it. We targeted the 2 first, so the opposite of plus 2 is minus 2 to both sides. We're left with the 3x because I haven't touched it. It's almost like I sniper shot the 2, and 3 is like, what? And 8 minus 2 is 6. From this step, you can almost say we can start our thoughts over again. This is now a one-step equation. We can identify what's my variable and what do I have to get rid of. So first step is what am I solving for? What do I need to keep? And what do I need to get rid of? So in this step, what should I get rid of? I see the 3. So the opposite of multiply by 3 is going to be, in this case, divide by 3. And we showed yesterday, I'm going to draw a little line for division. I'm going to divide 3 to both sides. Now again, just as a reminder, as I do something to one side, I must repeat that step to the other. Why? Because this is an equal symbol. And equal means I have to be fair to both sides. If I subtract from one side, I must subtract from the other. If I divide from one side, I must divide from the other. So in this case, I decided to divide the 3. And we can see here, the 3, what's 3 divided by 3? That's equals to 1. And we can just write x equals to 6. Oh, oops, sorry. X equals to 2. So we solve what x is. After we solved it, we want to go back and double check to make sure we did find the perfect fit. So if we say 3x plus 2 is equal to 8, just to rewrite it, we said x, my absolute solution here is 2. So now this is going to become the number 2. I'm going to write that with the parentheses. It's almost like I beamed it into place. X became 2. So x became 2. 3 times 2 is 6. 6 plus 2 is 8. Do we find a value that balanced out the equation, that would fit perfectly? I found my partner forever? Yes. So if x was 2, this would make this equation true. Okay, so let's review what we did. We said we start off with a problem. The problem up here was 3x plus 2, where we had one variable x we had to worry about. We said, hey, I need to solve for x, so we have to get rid of the 3 and the 2. 3 is multiplying, 2 is adding. So the opposite operations would be subtract for addition and divide for multiplication. We have to make a decision. Do I get rid of the 3 first or the 2 first? And you could get rid of the 3 first, but you have to make sure you follow the rules of math. So, and to make this a little bit easier so we don't make accidental mistakes, we say let's get rid of the thing that's farthest away. And what's farthest is the plus 2. It's not as closely bound to the x. Opposite of plus 2 is minus 2, and we do that to both sides. 2 minus 2 is 0, gone. So we're left with a 3x only. 8 minus 2 is a 6. We're following up with a 3x. How do I get rid of a multiply by 3? We divide by 3. So I'm really talking this out in my brain. Then 6 divided by 3 is a 2. 3 divided by 3 is an invisible 1. I don't need to write it. I can save time. I went ahead and double checked, and the solution was correct. So let's go ahead and try another problem. I'm going to make this more of a fraction problem now. So some of you guys could probably guess and check and come up with a solution that is absolutely right. Now, that works for easy problems. And in Algebra 1, our first semester, you could do that for a lot of problems. But we want to practice our steps so that we are comfortable with them when the problem gets harder. I could start guessing right now, numbers that I can divide by 5. 5, 10, 15, 20. And after I divide that number, I add 4. Which of those possibilities will give me 7? 100% okay. We do that naturally. We're always trying to jump to the answer. But let's use our opposite operations. And so our goal is to solve for x. Now, I'm going to ask you guys to take a poll right now. And you guys are going to select what my first step would be, okay? So we identified x as my variable. We said we have to get rid of the 4 and 5. 4 is addition, 5 is dividing, and the opposite operation to adding is subtracting. So we're going to subtract, and we're going to multiply for the 5. Now again, the big choice, the million-dollar question is, do I get rid of the 4 or the 5 first? And if you follow my rule from before, my general rule, get rid of what is farthest away. Get rid of what is farthest away from the variable. Which one's the farthest away from the variable? The 4 or the 5? And looking the way I wrote this, since 4 is like literally, since 5, the number 5 is next to the x, 4 is the farthest away. So that's get rid of the 4. And we do that by subtracting the 4. Again, my little hints here are more practical. So x, change color. So x over 5 plus 4 equals to 7. Rewriting it so you guys can have this nicely in your notes. I'm going to subtract 4 to both sides. And 4 minus 4 is 0. That's our whole goal, to clean this up on my left-hand side. And 7 minus 4 is 3. We start all over. Identify x is my variable. 5 is the number I want to get rid of. How do I get rid of a divide by 5? We're going to go ahead and multiply 5 to both sides. Use a different color here. Multiply by 5. I'm going to draw this with nice parentheses to make it look different. One reason why I'm writing with a parentheses because if I didn't, maybe it looks like 35. This might look a little confusing. So the parentheses is a way for me to organize my numbers to make them look a little bit easier for me and other people to read. So I multiply 5 to both sides. Multiply by 5. And this 5 divided by 5, like we showed before, cancel out. But divide out to become 1, x. And 3 times 5 is 15. So thank you everyone who wrote something. It is super important that you try to verbalize. I mean, we're not in class anymore, right? So by you typing it out, that is really positive, right? You're trying to work things out in your brain. So we didn't get rid of the 5 first. We got rid of the 4 first because it was farthest away. Now, just to double check this, I also want to double check for you guys. So if x equals to 15, x over 5 plus 4 is equal to 7. X is now 15. So I'm going to change that to 15. Now we can do the math. 15 divided by 5 is the number 3. 3 plus 4 is 7. And that is true. 7 is equal to 7. So 15 was my correct number. Now, I'll talk about why we shouldn't have gotten rid of the 5 first. It's actually not wrong, but a lot of kids make a simple mistake by getting rid of the 5 first. So if I multiply both sides by 5, let me ask you, am I multiplying just the front or everybody by 5? Okay, let me rewrite that with a different color, actually. See a little better. If I multiply the right side and left side by 5, am I multiplying just the front, or am I multiplying everybody? And the big deal about equals, imagine if someone gave your whole family a box of, have you guys ever had those huge tins of popcorn? Right? It's like a foot by like a foot diameter. So when they give it to your family, does it just go to one kid? Or does it just go to your dad or your mom? It goes to everybody. And the thing is, the popular mistake is that people do not multiply the 5 to everybody. They usually just multiply to the front. And that gives you the wrong answer. So let's do it the wrong way. So take a look. This is the wrong way. Wrong way. So a lot of people will multiply the 5 to the front, and they'll end up with 5 plus 4 is equal to 35. And then they'll minus the 4, and that's already wrong. That answer is not 31. So this is wrong, okay? Because you didn't take care of everyone. You weren't treating this like an actual equal sign. Because equal meant you have to multiply everybody on the left by 5, not just that front value. And it's a very common mistake, especially during summer. Since summer was just finished. So this is what you're supposed to do. This is the right way of doing it. And this is what we call the distributive property. And many of you guys have probably heard of it already. Sorry, whoops. We have x over 5 plus 4 equals to 7. And we're going to multiply both sides, I'll use a different color, by 5 and by 5. You can write your parentheses here if you want. You don't need to. So we're going to multiply to the front and to the back. So these 5s divide out. So we're left with x alone. But don't forget to multiply the 4 by the 5. It gets a 5 too. So that becomes 4 times 5 is 20, is equal to 35. Now, this goes back to a one-step equation. What's the opposite of plus 20? I can see that's a minus 20 to both sides. X equals to 15. So we could end up with the same answer, but oftentimes we make the simple mistake where we forget to multiply everyone by that 5 or by the constant number. Okay, so be careful about that. Let's do this. Let's see, one more time. Except I'm going to spin this around and I'm going to throw a negative sign into it. So 3, sign it. Okay, we'll say it's going to be negative x plus 2 is equal to 5. Negative x plus 2 is equal to 5. So we follow our rules like before. Our goal is to solve for which variable? Solve for the variable x. Now, in this case, there's more than one item on my left side. There's a 2, right? And there's also a negative sign. So whenever you see a negative, you can think of it also as a multiplying by negative 1. This could be thought of as the negative 1x. Okay? So I'm going to follow the rules that we did before. We're going to get rid of the 2. So opposite of add 2 is subtract 2. And in this case, opposite of multiply negative 1 is divide by negative 1. So I'll show you guys, there's 2 tricks of doing this. So we're going to go ahead and show you guys how to get rid of a negative sign in this class. Okay, so opposite of add is subtract, and opposite of multiply is divide. So there's 2 ways of doing this problem. Okay, here we go. We're going to negative x plus 2 is equal to 5. So make sure you are paying attention, especially if you struggle with negative signs. Opposite of plus 2 is a minus 2 to both sides. We're still left with a negative x equals to 3. Now, how to get rid of that negative? So I'm going to teach this method. I'm going to divide by a negative 1. You could just, like you can multiply both sides by a negative. I'm writing the negative 1 because you can't just write a negative sign just floating around, right, in the ether. You can't do that. So I'm writing a negative 1. What's a negative divided by negative? A negative divided by negative is a positive. Do you remember that? So this becomes a positive 1 is equal to, whoops, change the color. Positive x is equal to 3 divided by a negative 1 is negative 3. That brings me to a quick review about your positive and negative signs when it comes to multiplication and division. This rule works for multiplication and division. So positive and negative rules. And this works for multiplication and division. Some people like drawing the table. So if a positive times a positive gives you a positive. Let's use a different color here. Gives you a positive. A positive and a negative, you're still negative. A negative and a positive, you're still negative. And a negative and a negative, you become positive. Like if two people are talking and they both say nice things about you, that's good. If someone says a good thing, someone says a bad thing, there's going to be a fight. If someone says a bad thing and someone says a good thing, there's going to be a fight. Hey, but if you both say bad things, they both are in agreement. It's a good thing. Well, not really, but at least they're in agreement. And you guys all have had different ways of thinking about that. So the point is that if you only have one negative sign, you're still negative. You're still in the hole. But two negatives become a positive. And in English, it's the same way. If you can't go out. If you can't go out. So if you think of it this way, you can't go out, but now you can't go out. That means you have to go out. Okay. Another thing, when you guys are practicing IXL today, they'll write it in a funny way. They might write something like x plus negative 2 is equal to, let's say, 5. So they're adding a negative 2. So you can subtract the negative 2, and that will become a plus 2. Opposite of a minus is a plus. So x. So to make this easier on us, instead of trying to scramble our brains, you want to get rid of all your parentheses. A negative and a positive become a negative 2. So simplify it first. After you simplify, we can take this as an easy problem again. And we can try it. 7 plus negative 2 equals to 5. I think it's easier to get rid of the parentheses in my brain. 7 minus 2 is equal to 5 because the positive and negative stay negative. And 7 minus 2 is 5. And that is